There are many things that go into fabricating the molds for best-in-class molded pulp products. From the alloy you use to fabricate your screens, to the screening media itself, engineers and system developers must find the perfect blend of specifications to develop a sustainable process. It can be easy to generate a set of specifications based solely on the pulp slurry and nothing else. But it's also important to remain cautious of the deep drawing process needed to form the screen, as this will ultimately control the effectiveness and aesthetic of the finished molded pulp product. So what does deep drawing wire mesh mean? And what aspects of the process do you need to be mindful of? Deep drawing is a value-added process in which a flat, two-dimensional piece of mesh is formed into a three-dimensional profile. This process is particularly popular when producing molded pulp packaging, such as takeout containers. Not only does this maximize the screening surface area and allow it to fit snugly into your equipment, but it also ensures the mesh promotes an even distribution of heat and pressure throughout the mold. Since stainless steel, copper, aluminum, and brass can all be used to weave wire mesh for molded pulp applications, it is important to know that these alloys can, in fact, all be deep drawn. But that said, parameters surrounding the deep drawing process, such as the amount of pressure applied, must be fine-tuned based on the size of the mesh piece, the alloy of the mesh, and the depth of the draw. When deep drawing wire mesh, the mesh must be first cut to a manageable size and shape, then pre-formed to the mold profile. It is critical to be mindful of this step, as this is one of the leading causes of misformed mesh, which we'll get into in just a minute. So at this point, the mesh is loaded into a press machine equipped with a die that is furnished with a cavity representing the final mold profile. The press then drives the mesh into the cavity, causing it to accurately take the form of the die. After being pressed, the drawn wire mesh mold is then trimmed, removing excess material. The final step of the process is to add any sort of finishing coatings that your partial process calls for. Despite the durability wire mesh presents to the molded pulp industry, deep drawing can prove to be a delicate process. Having said that, cracked mesh, wrinkled mesh, deformation, and springback are all issues that can occur when the process is not executed with care. Cracked wire mesh refers to the occurrence in which the individual wires of the mesh begin to break in a focused area of the mold. It is a direct reaction of the mesh being drawn beyond its limits, and often occurs when the process is too aggressive, or if the mesh itself is of a low quality. Wrinkled wire mesh is used to describe the occurrence in which your wire mesh develops waves or folds while being deep drawn. Failure to properly lubricate the dies of the press, applying too much pressure to the mesh, or failure to cut the mesh to a reasonable size can all lead to wrinkled mesh. Deformation is a term used to describe the occurrence in which your wire mesh molds are not properly formed. This is often a result of wire mesh not having adequate support when being drawn. Springback describes the occurrence in which your wire mesh struggles to hold its form, causing it to spring back to its original flat orientation. In almost all cases, springback is directly tied to your wire mesh failing to undergo an accurate and thorough annealing process. While deep drawing may seem like a process that can be applied to any wire mesh specification, there are a handful of factors that can limit your ability to form molded pulp mesh molds. First and foremost is the alloy and quality of your mesh. Like I said before, there are several alloys that can be used to weave wire mesh for molded pulp applications. That said, these alloys have their own set of quality grades and characteristics that can affect how efficient your deep drawing process is. If your alloy or mesh quality doesn't match your deep drawing process, odds are you will frequently encounter cracked mesh. Another factor to be mindful of is the thickness of your wires in the mesh. Naturally, as the wires used to weave your mesh get thicker, your drawing process will have a harder time forming your mesh. When a diameter that is too thick is used, you increase the risk of encountering deformed mesh molds. As experimenting with wire mesh weave patterns can benefit the overall capacity and effectiveness of your molds, it is essential to know that some weave types don't draw well. This is because specific weave patterns, such as those seen throughout our mini mesh product line, feature complex patterns that become compromised. This in turn impacts the geometrics of the pore openings, rendering the mesh ineffective. And looking at the equipment you use, the accuracy and quality of your dies and other tooling can be detrimental to your deep drawing process. For example, if you're using stainless steel dies but you're forming aluminum wire mesh, galvanic corrosion can occur and cause inconsistencies throughout your molded pulp products. To that end, tooling that is not designed in accordance with your wire mesh needs increases the chance of encountering faults in your mesh. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.